Hello guys, welcome to my channel. Today Science and Technology. So in this video I am going to explain you about the structure of atom. So in previous chapter you have learnt about atoms. That atoms are the fundamental building blocks of matter, and also about the Dalton's theory, which states that all matter is made up of tiny particles called atoms. Atoms of different elements have different mass and chemical properties, and atoms combine in a small whole ratio to form compounds. So in this chapter you will be going to learn about the subatomic particles and the theories of the scientists given. So in 1900, a scientist named J.J. Thomson discovered the electron, which was negatively charged, and in 1886, E. Goldstein in 1886 discovered the presence of radiations in glass discharge and called canal rays. So these rays were positively charged, which led to the discovery of another subatomic particle named proton. So the electron was 2000 times less weighted than the proton. So the electron was negatively charged and the proton was positively charged. And many scientists gave the theories about the model of the atom. So we will be going to learn about the first model of atom. So it is the J.J. Thomson's model who discovered electron. So he gave the model of atom with an example of Christmas pudding, in which it is pair of positive charge fruits in the Christmas pudding, and electrons are embedded in it. So this is the example in which he told that atom is a positively charged sphere in which electrons are embedded in it. And the actual theory was that Thomson, an atom consists of positively charged sphere and the electrons are embedded in it. So as I told, the atom is a positively charged sphere in which electrons are embedded in it, and the negative and positive charges are equal in magnitude. So the atom as the whole is electrically neutral. So this states that the negative charges and the positive charges are in the same number, which makes the atom neutral. So he explained about the also he explained about the subatomic particles. This theory would not did not prove few other subatomic particles, and this theory was drawn back. So the next theory was given by Rutherford. So he was the person, he conducted first the gold foil experiment, in which he took a gold foil and beaten it into 1000 atoms thick. Also he took only gold foil because gold is, as you learned, that gold is malleable, so it can be beaten as thin as possible. So he bet the gold foil about 10,000 atoms thick, and he discharged the alpha particles, which were double charged lithium helium ions. So since so as you learned, helium atomic number is 2, so double charged helium ions means, so it is 4u. So the fast moving alpha particles has some amount of energy, and and so he expected that all the alpha particles were heavier particles than the protons. So he expected that the particles would just pass through the gold foil, but it did not happen. The observations he saw was that the most of the fast moving alpha particles went through the gold foil, just passed through the gold foil, and some some of the alpha particles, only few alpha particles were deflected, were moved at a small angle, and one in 12,000 alpha particles correctly rebound at 180 degrees. So by these observations, Rutherford gave about the model of the theory. So these are the points. So he told that most of the space in the atom is empty because most of the alpha particles pass. So he thought that positive charges were all over spread in the atom, but it did not happen because charges positive and positive repel. So if most of the atom was filled with by positive charge, which are proton. So as the one in 12,000 ray so deflected at degree 180, this made that the positive charges were very occupied very small amount of space in the atom. So he also told that electrons were revolving around the positive charged center called nucleus, and and the size of nucleus was very small compared to the size of atoms. So this theory was also drawn back because uh, he told that the electrons were revolving around the nucleus, which would have an thus conclude that these electrons would have undergo acceleration. So you have already learned that during acceleration the charged particles would lose their energy. So, and this and would fall. So if the electrons were revolving around the nucleus, it will undergo acceleration and lose their charge energy and fall into the nucleus. So then the any matter would not be stable, it would be disappearing in a few, at some amount of time. So at last there was one theory given by Niels Bohr. So he gave that there were certain orbits in which electrons would revolve, and during this revolution, it would neither gain energy or lose energy. So here are the points given by the Niels Bohr. So So, as you can see here that a picture of the four circles and in between a dot. So, this dot is the nucleus and these are the orbits in which electrons are rotating. So, first is the K shell which will be a number 1, and second is the L shell which will be number 2, and third is the M shell which is number 3, and fourth is N shell which is number 4. So he also gave few rules. So he also found new, during this before this time in 1932, J. Chandwick discovered another subatomic particle known neutrons. It has neutrally charged, neither positive or negative. So after this, there was a question raised in the scientist's mind. So how many electrons would fit in one orbit, and so how was the electrons distributed in different orbits? So they gave this made Bohr gave that few rules for this distribution of electrons. So the first rule was that, so here you can see the first rule: the maximum number of electrons present in the shell given by, so the what does 2n square means? So 2n square means that 2 into the what is the number of shell. So here you can see that in the picture they have given that the k is number one shell. So 2n square means that 2 into so the number of shell to the into the square. So for example, if we take the first shell k, so it will be 2 into, so the number of the shell is 1, so we will multiply it by 1, so we'll get 2. So 2 electrons will be fitting in that shell. So in the second shell, that is the L shell, so we'll multiply it with the 2, and the number of the shell is 2, so with the square we will get as 8. So the 8 number of electrons will be filled in this shell. So the second rule given by the Niels Bohr was that the maximum number of electrons that can be filled in the outermost orbit is 8. So he told that how many electrons can fit in the shells are maximum 8. So the electrons cannot exceed the number of uh, electrons in the orbit cannot exceed 8. And the third rule that was that electrons are not accommodated in the given shell unless the inner shells are filled. So the shell are filled in the stepwise manner. So